This is digital electronics lab. The experiment name is realization of comparator circuit and their truth table verification. We do 2-bit comparator. 2-bit comparator. Okay. First of all, we do the truth table. This input. Inputs are A and B. This output. We get 3 types of output. This A greater than B, A less than B, and A equals to B. So we can give 4 combinations 0 0, 0 1, 1 0 and 1 1. So for 0 0, both are equal, so it is high, and another 2 cases are 0. 0 1, so A less than B, so it is high, and it is 0 and it is 0. Next for 1 0, you also see that 1 greater than 0, so it is 1. A less than B is 0, A equals to B, also 0. And for 1 1, both are equal, so A equals to B 1, A less than B and A greater than B, both are 0. So it is a truth table of 2-bit comparator. From this truth table, we get 3 types of expressions. First, for A greater than B, this one, we get high only one case, that is A is 1, so it is A dot, B is 0, so it is B bar. Next, for A less than B, for this case, we see this one, it is A bar, this one dot B. A equals to 0, so it is A bar, and B equals to 1, so it is B. And for A equals to B case, we get the expression. First here 1, both are 0, so A bar, B bar, plus last one, both are high, so it is A dot. So we get 3 types of expression from the truth table. Now we see we need 3 types of gates. For bar it is not, for dot it is and for addition it is or. So 2 combination, 2 input A and B. First we take A and B. This is A and this is B. This A bar, this A bar, and this is B bar. So A greater than B, it is A dot B bar. So A dot B bar, this is B bar, this one, this dot, so it is and. So from there we get A greater than B. Next, it is A bar dot B. So it is A bar line, A bar, dot B. It is B line going to an AND gate. It is A less than B. Third case, first A bar B bar. So from here A bar B bar. This is A bar, this is B bar. Both go into an AND gate as a dot. Next AB. This A and this is B. Both are going to another AND gate. Then addition. So the output will be add. So for addition, it is OR gate. So for addition, it is OR gate. So from the OR gate, we get the A equals to B. So it is A equals to B. I think the circuit is clear. Now we have to give the pin number. We know NOT. For NOT IC, what is the IC number? It is 7404, and there are 6 gates, 1 input, 2 output, 3 input, 4 output. So we take first 2 gates, it is 1 and 2, it is 3 and it is 4. So not get in pin number. Okay, next go to the AND. We know 2 input and IC number 7408. There are 4 gates in the IC. First gate 1, 2, 3. Next gate 4, 5, 6. Third gate 10, 9 inputs, 8 output. And the fourth gate 13, 12 are the inputs, 11 output. Next, another gate is OR, 2 input OR, IC number 7432. There are 4 gates also. We take the first gate 1, 2, 3. Now the circuit is complete. So we here 2 inputs A and B and 3 outputs. First A connect to the pin number 1 of NOT and B connect to the pin number 3 of NOT. Then we connect this one line. It is considered of one line of NOT. It is 2 line of NOT, it is 3 line of NOT, and it is 4 line of NOT. So from 1 we short 1 and 1 of NOT and IC. Next from pin number 1 of AND and pin number 12 of AND, you can see shorted. So one line is completed. Next go to the second line of NOT. Second line is connected pin number 2 of NOT and pin number 4 of AND are shorted. Next pin number 2 of NOT and pin number 9 of AND shorted. Next go to the pin number 3 of NOT. Pin number 3 of NOT and pin number 5 of AND are shorted. Next pin number 3 of NOT or pin number 5 of AND and pin number 13 of AND shorted. You can connect 13 from either pin number 5 of AND or pin number 3 of NOT. Next line 4 line of NOT connected to 2 of AND and 10 of AND. So these connections are completed. Going to the here. From 3 of AND we get output, that is A greater than B. From 6 of AND we get another output, that is A less than B. And there is another connection. Pin number 8 of AND and pin number 1 of OR are shorted. Pin number 11 of AND and pin number 2 of OR are shorted. From pin number 3 of OR we get A equals to B. So 3 output, 2 input. I think the circuit is clear. Now we check the circuit in analog and digital tenor kit. You can check the circuit if you have available in your house. you require only plus 5 volt, breadboard, IC, 3 type of IC and connecting wire. Okay, we have 3 ICs. This is 7408, this is 7408, and this 7404 not, and this is 7432 all. So first connect 7404. Next AND at the middle position. So not AND and all. As per circuit, we get two inputs. We take two inputs. First input going to pin number 1 of NOT. We connect VCC to pin number 14 of all IC. Get from the kit only one connection, so you have to short it to each IC. Pin number 14 to pin number 14. Next pin number 14 to pin number 14. So now plus 5 volt are connected to each IC. Next ground. Ground will be connected to pin number 7. It is connected to pin number 7. Next pin number 7 and 7 will be shorted. Same pin number 7 will be shorted. It is our first work to give plus 5 volt and ground to each IC. Next, one input is connected to pin number 1 and another input is connected to pin number 3 of NOT. Next, pin number 1 of NOT will be connected first. So from pin number 1 and to pin number 1 of AND, pin number 1 of NOT and AND will be shorted. Next, pin number 1 of AND, you can see in the circuit, take the rough sheet in front of you. Pin number 1 of AND and pin number 12 of AND. Pin number 12 will be shorted. So one connection of NOT is completed. Now go to the pin number 2 of NOT. So pin number 2 of NOT and pin number 4 of AND. Pin number 2 of NOT and pin number 4 of AND. 1, 2, 3, 4 is shorted. Next, pin number 4 of AND or pin number 2 of NOT. 4 of AND and pin number 9 of AND shorted. So two connection of NOT completed. Next 3 of NOT. From NOT 3 it is going to pin number 5 of AND. From 3 it is 3. Pin number 5 of AND. From 3 it is going to pin number 5. Pin number 5 and 13 of AND shorted. Pin number 5 and 13 is pin number 5 and 13 are shorted. So 3 connection complete. Next 4 from pin number 4 of NOT is connected to pin number 2 of AND. Next pin number 2 of AND and pin number 10 of AND are shorted. Pin number 2 and 10. 8, 9, 10 shorted. So internal connection are complete. Next pin number 8 of AND and pin number 1 of OR is connected or shorted. Next pin number 11 of AND and 9, 10, 11. 11 of AND and pin number 2 of OR also shorted. Now connect the output. So first A greater than B is connected to from pin number 3 of AND. This one. Next output from pin number 6 of AND, it is A less than B. Another output A equals to B, A equals to B from pin number 3 of OR. Now we check the truth table. For 0 0 it is 0 0. For 0 0 you see the output, it is A greater than B first, this is second, this first A greater than B, you can see it, A greater than B, A less than B, and third is A equals to B. The first LED, second LED, third LED. If it is glow, it is high, it is considered as high. If it is not glowing, it is considered as 0. So for 0 0 input, you see, for 0 0 input, now it is same. For 0 0 input, the A equals to B, LED is glowing, so it is 1. For 0 1, that is A less than B. Second output, it is A less than B is glowing. Now for A greater than B, you can see 1, it is 0, it is A, it is B. So A greater than B, it is glowing. And the fourth combination, that is 1 1. For 1 1, A equals to B is glowing. So it satisfied the truth table. Now I want to tell something, that for NOT IC we have to check these two gates, that is 1 2 and 3 4, and check the truth table of NOT. For AND IC we use 4 gates of AND, so we have to check these 4 gates of AND. And the OR IC we require only 1 gate, so we have to check the one gate, first gate or second gate or third or fourth. After checking all the gates of all ICs, then we have to design the circuit. Because after design the circuits, if you don't check the IC, gate of the IC, and the output is not satisfied, then that maybe the gate may be damaged. So if we check the gate first, then we sure that the gates are okay. There may be some loose connection or internal connection, so the output is not satisfied. So you have to check the gate first, and you make sure that the all ICs are connected to the ground and plus VCC. Then switch on the power, because it is a DC component. If suppose you give plus 5 volt to pin number 7 and ground to pin number 14, then the IC will be burned. We know for DC component we have to sure the connection, then connect. Thank you.